All right, let's start with this. These questions might be a little bit easier than the ones that are on your test. Some of them are comparable, so just keep that in mind. So if you look at number 1, there is no adding and subtracting, so there's no factoring. So let's see, 4 goes into 2 2 times. There's 6 on top, 4 on the bottom, so there's 2 more on top. Well, y cannot equal 0. Okay. Number 2, factor the top. If you copy this, you're not going to get better at factoring. You've got to practice your factoring and make sure you're good to go. This should just be checking and making sure you're no problem. Okay? Number 3, I'm going to take out a -1 because I notice these all have negatives down here, so I feel like if I do that, then it'll match up to cross off. You don't have to do it my way. This is just what I think is easiest. And then now I can factor this. Let me put the -1 up there, so that's gone, that's gone. Factor this. The negatives are gone. Oops, let me make that a little bit bigger. Sorry about that. X minus 4, x plus 5, or x can't equal -5. Okay. All right, let's get a little bit more complex. So for me, I feel like this is a lot going on. So 5 goes into 24 times. 4 goes into 16, -4. 4 over -4 is -1. Now for me, it's easiest to add all the x's and the y's, and then decide if there's more on top or bottom. 1 more x on top, 2 more y's on bottom, negative, or y cannot equal 0. Okay, the key to this one is you've got to flip when it's division. Okay, factor this because there's a plus. Now I can start crossing things off. X plus 1 on top, x plus 1 on bottom. 3 goes into 9 3 times. I have 3 on top and 1 on bottom. So I have 2 more left on top. And I'm left with x squared over 12. There's no restrictions. I definitely could have made a little bit of a mistake here and there, but you get the game. All right, key on this one, flip it, because it's division. Sorry. Factor the top. These are very similar in their factoring. This is definitely a level A kind of thing. So I would make sure. This should be no problem. If you're struggling here, the next review is going to be a lot scarier. So make sure that you're solid on this so that when you get to the next review, you're not freaking out. Okay? All right. The bottoms are the same, so I just add the top. I can tell that I can't factor the top, so there's no more crossing off, where x cannot equal -1/2. Okay? If you're struggling on how to get the -1/2, there's nothing wrong with going 2x plus 1 equals 0. -1 minus 1. X equals -1/2. Same thing I got there. Whatever you want. Change the sign of everything to the right. Ugh. So this has an x plus 1. I got to give this an x plus 1. This has an x plus 4. I got to give this an x plus 4. And the key is you've got to distribute, distribute. Distribute, distribute. Don't forget the negative. And then I'm not going to multiply that out because they're my restrictions. And then I can simplify the top. I know there's no way to multiply to get 3 and add to 1. So comma x cannot equal -4, comma x cannot equal -4. Okay, let's go to number 9. Change the sign of everything to the right. I can factor this. This has an x minus 9. This has an x minus 9. This has an x minus 4, so this needs an x minus 4. And then distribute, distribute. 7x minus 28 minus 2x plus 6 all over this. And then I can put the same together. I can tell I can't factor the tops, so I'm done simplifying. I'm good to go. Okay. All right, let's turn the page. All right, these ones are a little bit more complex, so let me go over it. This line right here, this big line right here, means divide. One of you have this on your project. So this is really 3x over 3x plus 21 divided by 9x squared over x plus 7. Which means now whenever it's division, you flip it. I can factor out the 3. And now I can start crossing things off. X plus 7, gone. 3 and 9, 3. X is on top, so there's one more left on the bottom. It doesn't look like I have anything left on the top, so since I don't have anything, I have to put a 1, and then 3 times 3x is 9x, where x cannot equal 0. Same thing for number 11. This big old line means divide. Divide means I flip it. So this is really going to be factored x minus 2, x plus 2, and this is x plus 3, excuse me. X minus 2 gone. That's on top. That's on bottom, where x cannot equal negative 3. Okay, last one. 12 over x plus 3 divided by x squared plus 1 over x minus 2. Divide means I flip. I can't factor anything, actually. And I can't actually cross anything off. So my answer is 12 over x minus 2 divided by x plus 3 times x squared plus 1. Now, it's only where x cannot equal negative 3, because if you set that one equal to 0, so let me do this. I get x squared plus 1 equals 0. X squared equals negative 1, square root, boom. That means it's imaginary. If it's imaginary, then it's not a real value for x. So it's not one of your extraneous solutions. It's an imaginary solution. Be aware of that for your test. All right, let's get into some graphing. So remember, this means I'm going to go right 3, vertical asymptote. So my VA is x equals 3. Lower that a little bit. My HA is 5. So my HA is y equals 5. Top right. Bottom left. If I'm talking about transformations, let me zoom out a little bit. Horizontal translation, 3 units right, not a straight shooter. Vertical translation, 5 units up. The y is a straight shooter. My domain, all real numbers, but x cannot equal 3, because that's the asymptote. Range, all real numbers, but y cannot equal 5. Okay? So now let's look at number 14. All right, so for number 14, we're going to see if we can factor. And that's minus, and that's plus. So I did some guess and check, and I factored that, okay? Okay, so I need to figure out my VA, my HA, I need to figure out my zeros, I need to figure out if there's any holes. Okay, there's only a hole if there's a repeat. There isn't a hole because this doesn't match that and that doesn't match that. So there are no holes, okay? Your VA is based on the denominator, so you set that equal to 0, x equals 4. Okay? Now remember the rule for your HA. Your HA is based on the leading coefficients. Because the degree of this is greater than the degree of this, there is no HA. Okay? And then your zeros are based on the numerator, because if you set that equal to 0. So that means your zeros are negative 1/2, comma 0. I really should have found a different place for this. Sorry. And 2, comma 0. So those are your zeros. Okay? So then I'm going to graph this at x equals 4 vertical asymptote. And then my zeros negative 1/2 and 2, 0. There are no holes. And honestly, I'm not going to give you one where you have no idea how to graph it. I'm going to give you one where it's kind of clear. So just fake it a little bit, show that it almost hits that, but it doesn't. I don't know. I'm just making it up, okay? I don't know how it's going to look exactly. But just show that it goes through that, and it's never going to hit the asymptote. Okay? And I guess that's it. All right, let's try the next one. The next one, VA, HA, zeros, and hole. Okay? So the first thing I'm going to do is I think I'm actually going to go lower here because I don't have much space. I'm going to factor this. X plus 5, x minus 1 over x plus 1. Okay, I wish that one had a hole, but it doesn't. So holes are the ones that means they repeat. This does not repeat, so there is no hole. Okay? The zeros are based on the numerator. Oops. So that would be negative 5, 0. And 1, 0. Okay? Your HA, I don't like, it's like the exact same problem. There is no HA because the degree of that is higher than the degree of that. But I guess it's good practice for you, right? If you can do that one, then that means you learned from this one. Or you already knew how to do it. So that would be x equals negative 1. X equals negative 1. Negative 5, 0. 1, 0. I don't care how you graph it, but if you have this going through that, that doesn't happen. Okay, it's not possible. So I don't know, let's go like, I'm faking it, okay? It doesn't matter, but you just need to show it's approaching. You can even show it's approaching like this. I don't care. Okay? All right. Let's solve. So remember when we're solving equations, the goal is to get rid of the denominator. So, I can factor this. So give everything an x plus 1, x plus 1, x plus 1. Give everything a 4, and a 4. This already has a 4, and this already has an x plus 1. So let's cross off. And now 4 times x, 4x plus. The 4 is gone. And distribute that x squared plus 1x. And then gone, 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 gone. So just equals 3x. Anytime you have a squared, you set it equal to 0. So you put these two together. Subtract from 3x. Take out an x. X equals 0. X equals negative 2. Plug it back in. What would make it extraneous is negative 1, but you didn't get that, so you're good to go. This one's the same thing. Give everything an x minus 4, x minus 4, x minus 4. Got it already there. Give everything a 2, and a 2. Now cross things off. Distribute. Cross things off. Oops, sorry about that. Distribute. Cross things off. Distribute. Once again, it's an x squared. Set it equal to 0. Put these two together. Subtract 8 to both sides. I feel like I might have done something wrong, so let me check. Let's see, so I'm left with 2. Let's see, negative 2x, x squared minus 4x. All right. This one, none of them work, so you'd have to do the quadratic formula. If you do the quadratic formula on the test, you're doing something wrong. I'm not going to torture you like that. Okay? This one, factor this, x minus 2. I might have made a mistake somewhere, but I only have 15 minutes for this video, so I got to make sure I get every problem in. All right. X minus 2, x plus 2. X minus 2, x plus 2. Buff by, left with a 4. Buff by, left with an x plus 2. X equals 2. Uh-oh, extraneous. There is no solution. Okay, so that